Yeah. All right. Make sure I'm on here. I think I am. Yep. Okay. So as it turns out, the next things that we're going to do, we're going to have a lot more formulas. We're not going to always going to be able to take the time to make sure everything is set up exactly. We're going to have to go a bit faster now through the rest of what we have. Okay. So hoping that everything has been settled with these particular formulas, then we do have, as we just did, the idea that if you change the size of the sample, it affects the accuracy of the problem. So then there's another formula that we can use that works off of that connection. And this is, again, on the list of formulas that we have under chapter 7. And this is the sample size for a proportion. What this allows us to do then is to say, how many people should I talk to in order to get the information that I want? Okay? Now, this is what they call a ballpark number, okay? The exact number of people is not going to be the answer here. This is going to give you just an idea of how approximately how many people you would need to talk to or the size of your sample in order to get the information that you want. Okay? So let's say that I want, well, first of all, we're going to write the formula. N, P hat, Q hat. And then we have this thing, B of alpha divided by 2 over capital E squared. Okay, so this is the formula that we're going to use. So let's talk, well, might as well keep the same example. I want to find out, I really am concerned about this whole Yahtzee phenomenon. And I really want to know how many people have played Yahtzee in the past. And so I'm going to decide here about my amount of confidence, which will give me my z-score. And I'm going to have to figure out how much a margin of error I want. Okay? The amount of confidence will give me the z-score. The margin of error is what I pick. I pick that as well. And then we have the p hat and q hat. We're going to use the same ones that we had previously. Okay? So let's say that I want a 95% confidence interval to be accurate within 3%. So again, I'm choosing my confidence level and I'm choosing the margin of error for this. Now, if I say I want a 95% confidence level, what z-score corresponds to that? 1.96. So I know that from what I did before. 1.96 is my z-score. If I say I want to be accurate within 3%, what that means is I could be 3% high or low. Okay, my answer could be 3% either side. So that means my margin of error, this is where some people have trouble, it's 0.03. Even though I said 3%, when I put it in the formula, I put in the decimal number. So n now is equal to 0.7 times 0.3, and then I have 1.96 over 0.03 squared.
And we can do this for month, right? I like the exponent first, then we don't have to do like part first. So
That E stands for accuracy or
E is the margin of error.
margin?
Okay. When you put this into your calculator, if you want to put it all in, you're going to have to put parentheses around the 196 over 03. Or you could do that, square it, and then multiply it by each of the equations.
Do you hit equals in the square or square in
I
the?
didn't get that.
Yeah.
Yeah.
That's what I got.
If you're putting in the whole thing, you hit square and then you, but you have to have the parentheses there.
And then we go times parentheses.
Okay, you should come up with 896. And once again, the idea here is that when we're talking about these things, proportions, percentages, whatever you want to call them, you're probably going to need hundreds of people or maybe 1,000 people in order to get a really accurate result. If you're just talking to a handful of people or people in a classroom, your answer is not going to be very accurate. So you need to have a couple of hundred people or even up to 1,000 if you really want something that's relatively accurate. And you can get a general idea with a small group, but if you really want accuracy, you got to go up as much. Now, just so that you see this, let's say that I type into my search bar CNN margin of error. And let's say we go to past month. Okay. Too early to tell if a Korea success. Okay, I believe that. Too early to tell. I accept your cookies. So it has all this stuff, and it says this poll was taken June 13th through the 15th. It surveyed a total of 495 adults with a margin of error of 5.5 percentage points. That's a confidence interval. Whatever numbers they're giving us here are plus or minus 5%. Because they talked to 500 people. Okay, so when we see this and we say 21% called it a success for Donald Trump and 29% said it's a success for North Korea, those are not the numbers for the population. Those are the numbers for that particular group of 500 people. If you say, what would this be if we talked to everybody? Then it could be 5% either higher or lower than any of these numbers. So anytime you see a survey out there, CNN is pretty good about telling you what the margin of error is. Other places aren't as conscientious. But at least here, if you go all the way down to the bottom, you'll see that these numbers are not real. This was just a group of 500 people. So plus or minus 5 or 6% to get the actual results. This is why when people talk about political races, if something's like 50% or 52% or 53%, it's too close to call, because you'd have to talk to 10,000 people if you really wanted to know what the thing was, and they just don't. Because by the time you talk to the first 1,000, the other 9,000 have changed their mind. So it's really hard to get very accurate information in real time for any kind of political thing, because things change so quickly and you need tens of thousands of people to get a very accurate result. So this 500, pretty much they say close enough. That's as good as we can get. So you can't really know what's going to happen when people make these polls. Fact is, you don't. Of course, you never really do. But at least we're able mathematically to say within 5% based on all this stuff. And this is how you would think about how many people you need to have for a certain level of accuracy with a certain level of confidence. All right, so that being said, we're now going to move into our next thing, which is the mean. I want to know the different symbols for the sample mean and the population mean.
What do you want?
I want symbols. I want to know what is the symbol for the sample mean and what is the symbol for the population mean.
Sample is X.
Sample is X bar. Population, it is mu. Right? So when we say, I want to know something about the population, that means we're trying to find something out about this mu. But we don't know what it is, because all we have is sample information, which is X bar. Okay. Now, as it turns out, Z doesn't work for the situation. We thought Z would work. It would seem reasonable, but it doesn't. Because if you remember when I did that whole thing, when we were talking about the sampling distribution and all this stuff, we had to actually know the standard deviation before we could do that problem. But we don't know the standard deviation because we're working just with sample data. So that means we have to do something else. So then, when we look at our situation here, we need to use a different formula, which we can pull up from our formula list. And let's see if I can make it bigger enough. Okay. So this is what we want. We're not going to do sample size, but we are going to do the confidence interval for the mean. It has T instead of Z. That's correct. So it looks like what we had before. It's similar. There's a few differences here, of course. And it's using a T instead of a Z. So we're going to write it up here. Now the question that needs to be addressed right away is, what are we actually looking to find? What is the information that we have, and what are we trying to figure out about that information? In the previous situation, we were asking the yes or no question. Have you played Yahtzee? And we were just putting people into categories based on that. But now we're actually asking people for a number. Like, how many board games do you own? Okay? So we're going to use that as our example. How many board games do you own? And we would have some kind of a list of data. All right, let's just use a few people here. Let's go with the back row. Donna, how many board games do you own?
0.
0. Abby?
4.
4. Baylor?
1.
1. Humphrey, do you own board games?
3.
3. Nikki?
I think like 10.
10. Oops.
Emily.
Kelly, thank you.
Yeah, probably like 5.
5.
I don't know.
All right.
A bunch.
So here we have a list of people and a list of how many board games they own. Okay? In order for me to work this problem out, I need, from my sample, I need 2 numbers. I need the mean and the standard deviation of the sample. The mean is X bar. Standard deviation in this situation is S. It's from the sample. Okay. Now, what's going to happen in your homework is that you're going to be given a list of numbers like this. So what you're going to need to do is find the standard deviation and the mean of these numbers. I recommend that you not do this by hand. I recommend that you use Microsoft Excel, put the numbers in, and find the mean and the standard deviation. So that's what I'm going to do right now. I'm going to type, oops, not Excel Energy, EX. Okay, and I'm going to make this bigger, 24.
It's just so that like we don't put something wrong into our paper that we have to use Excel.
If you want to spend maybe 3 extra hours doing your homework, then I would say you could, but I don't recommend it. I recommend that you do it this way. All right, so I've got 0, 4, 1, 3, 10, and 5. Okay. So I'm going to hit the equal sign, type the word average, left parenthesis, select the data, enter. We've done this before. We all went over to the other room so that you would know how to do it right now. Okay? So I hit the equal sign, I type the word average, and then I select the data, hit the enter, and I find the average of my data. And I'm going to say it's 3.83. Now I'm going to find the standard deviation. S as in Sam, T as in Thomas, D as in David, E as in Edward, V as in Victor. Once again, select my data values, enter 3.54. So I have X bar, I have S, standard deviation. What is N in this situation?
The number of people in the sample.
The number of people, which in this situation is 6. Now I need T of alpha over 2. Once again, it's not T multiplied by alpha and divided by 2. I need to find out what my alpha over 2 is. Then I need to find the T that goes with that. So if I go with a 95% confidence interval, I'm not going to be able to use my Z like I had before, which was very convenient. But now I need to look it up somewhere else. What is my alpha over 2? Well, I know alpha is 0.05, so alpha over 2 is 0.25, just like it was before. Now I want you to look on your tables that I gave to you. Table F as in Frank. This is the T distribution. The T distribution is different, but I'll show you how to do the T distribution. In this situation, what do I have for my confidence interval? 95%. Where am I going to look? Well, right here, confidence interval, 95%, right there. I'm going to be looking in this column. However, I have this thing, which is going to tell me what row to look in. This is called degrees of freedom. And I've just got to apologize in advance. Statistics is really messed up, and it's messed up right here. Sorry. Degrees of freedom. Degrees of freedom is equal to n minus 1. So in our current situation, degrees of freedom is 5. I need to find the t-score. Degrees of freedom is 5. Confidence interval was 95%. 2.571. This is the number that's going to go in there.
That's T.
This is T of alpha divided by 2. I find 95%, which would have 0.25 in one tail. And I go down to the correct degrees of freedom, 2.571. So this is what I need to do. So yeah, I'll let you try that out on your calculator. See if you can get what that number is, which would be to the left. And then I have a plus sign, which would be to the right. Okay. So let's see if we can make that happen. All right, check with your neighbor. See if your neighbor's got stuff going on here.
If you put, yeah, it doesn't say.
Okay. You also want to express that.
No,
No,
these are not percentages anymore.
okay. So you just want to end,
Oh, he said enough.
line is less than you.
Yes.
Okay.
All right, so 3.83 here, standard deviation 3.54, N is 6, alpha is 0.05.
Yeah.
Okay. Nope. 0.571. So 0. And we'll just go to the hundredths place here, 0.11, 7.55. All right. So once again, we're asking the question, what does this really mean? I asked 6 people, how many board games do you have? They told me a number. So I'm measuring a number. That number, I want to know what is the average for everybody, not just for these 6 people. For the 6 people, I came up with 3.83. Okay. After I got done, I found the mean was 3.83, standard deviation 354, n is equal to 6. I went through this whole process. At the end, now, what I'm going to say is the population average is somewhere between 0 and 7.6. Okay. And what am I talking about? The average number of board games that people have. Now, if I'm trying to sell board games to people, is this helpful information? People out there have between 0 and 8 board games. That's not very accurate, right? So once again, because my sample is really small, I'm not going to get a lot of accuracy with this. But my accuracy is also affected by this thing, the standard deviation. So if my sample has a lot of variation in it, then this is going to be very inaccurate. So it's combining everything about these numbers, putting them together and saying, what's the actual average? Somewhere between 0 and 8. Well, that doesn't help me a whole lot. But this is the process that we're going through to try to figure out what is the number. Now, we could go through and change the confidence level. We could go through and change the sample size and all that stuff. We're not going to do that because we have another thing to do, and that is the standard deviation. So, we erase everything. I want to know the symbols for the sample standard deviation and the population standard deviation. That is correct. The population standard deviation is lowercase sigma. The sample standard deviation we already have, it's S. Okay. Now,
Lowercase sigma.
yeah, this is lowercase sigma. Okay. Now, remember, numbers are always changing. Okay. So it might be good for us to ask the question, how much are they changing? Which is what the standard deviation tells us. Let's say, for example, you want to invest your money in electronic companies. Do you want a company whose price goes way up and way down all the time, and you have no idea what it's going to do from one day to the next? Or do you want something that's very stable and it's consistently a certain number? Well, most people like consistent investments. They want to make money and they want to keep making money. They don't want it to go way up and way down. So that would be a situation. Let's talk about how many nurses you're going to have in a hospital. Is that number going to change significantly from day to day? If you have two different hospitals and one of them, the number of nurses swings wildly up and down, and the other one is more consistent, you'd probably want to be in the other one, right? Okay, you don't want a place where the number of personnel is just crazy weird. You'd like to have it more consistent. So that's what the standard deviation tells us. So we want to know what is the actual standard deviation of a set of data. Not just the sample, we want the population. Well, again, I have to apologize ahead of time for this, but here we go. Here's the confidence interval for the standard deviation. So then we might ask the question, what is that symbol down the bottom in the denominator of those fractions? It is not an X. It is not just a funny looking X. It's a Greek letter, of course. And this Greek letter is called chi. And if you'll notice, it has the 2 up there. So this is called the chi-squared distribution. It's not Z, it's not T, it's chi-squared. Now, is it chi? It is not. All right. Actually, there's a very common word that we use, and that's Christmas. First letter in the word Christmas is chi. So when we say, we don't say Christmas, we say Christmas. So we say chi-squared, right? All right. Now, it's unfortunate that this particular textbook uses the word right and left. I'm going to tell you what those mean using alpha, close to what they have. Okay. So when we say right, in this situation, we mean alpha over 2. When we say left, it's 1 minus And I'll tell you this on the test, I'll give you this phrase. Because I don't think it's a very good idea to keep you completely in the dark about what you're doing. So there we go. All right. So, do we know n minus 1? Yeah, we do. We got 6 things, so n minus 1, that would be 5. Do we know the sample standard deviation? Yes, we found it. So really, all we need here are those numbers, those chi-squared numbers. So that's table G, which you have on the back of table F. Okay. So we are doing chi-squared. Table G. Degrees of freedom. N minus 1, which we already had. Okay. So in this case, degrees of freedom is 5. So what number do I need? The first number I need is alpha over 2. What's alpha over 2? Well, if we have a 95% confidence interval, alpha is equal to 0.05. Alpha over 2 is 0.025.
Hold on a second.
.025. 5 degrees of freedom, 12.833. Now, where's chi-squared left? Correct? What's 1 minus 0.025? Nope, 0.97. Put that 0 in there. Do we have a 975 on there? Sure do. What's 975? We go down here to degrees of freedom is equal to 5. That's 0.831. That's chi-squared left.
Right. That's good, right. How did you get right?
Right is alpha over 2.
Yeah,
Alpha over 2 is 0.025.
yeah,
0.025 is right here.
okay.
Degrees of freedom is 5, right there at 12.833. That's chi-squared right.
So could you say to find, like, okay, to find x,
Chi.
okay, chi squared left is 1 minus, yeah, alpha over 2. No, 1 minus alpha. Yeah.
Okay, yes, that's what I said. Left means 1 minus.
Oh, it's
alpha
right
over
in
two.
front of you.
Yeah, there you go. Okay. Yep, there it
Just
is.
didn't click.
So now we put in the numbers. Square root of 5 times 3.54 squared over 12.833. Five, 3.54 squared over 0.831. we go nuts.
How does that happen? We do square root. How do we do this? We go for it.
Okay, square root, parenthesis left, 5 times 3.54 squared divided by 12.833, parenthesis right, equals. Which should come out to be 2.21.
Oh, I didn't do the terms. I just typed in. What is it, 5 times parentheses?
Okay, here, this is just showing you multiplication. You don't have to put this set of parentheses in.
So when you do it in your calculator, do you do
But
square root?
Square root, left parenthesis, all that. Right. Oh yeah, we're right on time, 8.68.
Can you just tell me one more
Oh,
time
yeah.
where you found the left? Yeah.
This one?
Yeah.
Okay, I took 1 minus alpha over 2.
Yeah,
That's 0.975.
yeah, so we're,
So I'm on the table. I go over to 0.975. I go down to the 5th row, it's 305. And that's 0.831. Now you're gonna hate me, I realize, but I'm gonna say one more thing to you. What do we do if we need to find the variance? We would square these numbers. Once we got them, we would square them. And that would allow us to do our homework, which is positive. Okay. So on the homework, when it says find the variance, you don't find the variance, you find the standard deviation numbers first, then you square them, and that will give you the variance. So yeah, that's enough for today. And I'll plan to see you on Monday.
I'm going into this in my calculator. I was finding like a different alpha.
Oh, okay. So, start with that.
my roommates are in the coffee right now. Yeah, she's like.
Divided by square root.
Mm.
like, did you
Okay.
do a project?
Yeah.
All right.
Yeah, thank you.
Sure, you're welcome.
Average for dermatology is considered agriculture issues. Dermatology is like a complete project. You should do both the transcripts and the project. He's like, what exactly is the project then? I'm like,
Oh my God.
I'll tell you what it is. Yeah.
Do you know what I told
I just like
Kayla that
Yeah.
I painted a picture for mine, but mine took 2 days.
Yeah. I got mine done in like a night, but it took me like a good 2 hours to do it. Because I like hated it so.
I was feeling these at a little Walmart and bought it, and she's like, and she's like, here you go.
She didn't even mention anything about liking pictures.
Like, I'm still doesn't type that test today.
Oh, sure.
Yeah. Why would you literally
All right, we'll find out. Open Google Keep. Get whiteboard cloths from Betsy. Hey, kind of warmish in here, maybe.
Oh, it's way worse outside.
Oh,
Hi.
oh, it is, though. Let's turn it down. Oh, it is. Oh, well, sorry.
That's all we can.
I hold on. I think
I'm so glad her son is up until Friday.
Oh, is it really?
Oh, I was like, you know
I
what?
I did it.
I didn't do it, because I got to count that as a loss, but they sent me that.
Huh. It was really easy though. You know how usually she has examples and there's none? There isn't, there's only 3 out of the like 17.
What is everything?
It's more like what's forgery, what is meant by this, what is meant by this, what is meant by that. So no, no, I've been taking Mike's discussions as an L lately. I've been,
I just read it, I saw like the other week, it was just me and Mara that posted.
yeah, that's why.
Yeah, this.
I went on at midnight.
And I got 30 on that, I was like,
It's been like 3 weeks.
English feature is just like.
why don't you wear a backpack?
Yeah,
Sorry.
Because.
he went to the gym.
Okay.
So lucky, yes.
Um,
Guess I can punch you out.
That's why I skipped yesterday.
For the gym?
Yeah, because someone was like, yeah, they was outside just barking now. And
I
like,
was there, I was in
like,
the
you just
parking
got
lot.
to come, like.
I was in the parking lot, I stepped out of the keys and damn wrong stuff.
Sorry, I don't have no.
Do you
Yes.
want?
Yeah.